Hi, welcome back to Spring CS170. Just gonna step into debugging right now. This actually is kind of a short chapter in the book. Um, it's a bit hard to really go into a lot of things about debugging. It's not like you memorize a formula and then you can do debugging, right? Back to the idea of like heuristics um, versus an algorithm. So you can look at like general rules of thumb to help you with debugging. There's a couple of different angles on that, but I'll step into that for you. And then I'm also going to cut a separate video of me actually going through a debugging example. So you'll get both of those videos up shortly. So stay tuned for that. Okay, so here we are. This is week 6. Here's the textbook. This is in your resources. And we're going to be covering 6 and 18 chapter, right? Chapter 6, chapter 18, and you can see here's these couple of things here for chapter 6. So it's not really that much, but let me step it through here. In fact, in my PowerPoint, I only have like this one page for it. So let's go. So on debugging, basically you might have seen it if you've been playing around with the HTML and JavaScript stuff. Um, it's basically 3 categories of errors. You get something called a runtime error, a compile time error, and a logic error, right? And I'll have examples of those for you in a second. So runtime error is something that, the thing just blows up or doesn't work while you're running. But, as you're running through it until you hit it, it looks normal. It doesn't look like anything's wrong, right? Compile time error is something that it just totally bombs out before you can even do anything, right? So it's such an egregious error that it doesn't understand it, and like it just goes kaput. You can't even get into the program. A logic error, like everything seems to run fine. There's no errors that gets generated, but you're not really getting the output that you expect, right? So it's almost kind of like a hidden error, right? It's not very obvious as to what the error is, right? It's not like the computer can read your mind. You intended to do one thing, the logic produces something else. That's the whole point of a logic error, right? So let's step out here a second. So I went back into JSDO and set up a couple examples here. All right, and so let's say I did this, right? And you kind of see this up here at the top just because I ran it already. So let me clear that. So I run it, and it's fine, right? Don't worry about some of these things here we didn't cover yet. We're going to though. But basically we have a button here, right? And the button is going to call a function, right? And it's going to be this on click there. So don't worry about that part. That's not the important part, right? And then here's the function, and there's some stuff that it's doing here, okay? And this is a comment here, right? So you see this like that and like this. That means this is not really code as the computer understands it, okay? So I click on it, and you get value 1, 2, 3, which is right here, right? So by me hitting this, it calls this function, then it starts going through here. So from last week, you remember here's like the assignments, and then I did this display here. This is an alert, right? Pops up this little box here, and it says A, right? A is 1, 2, 3, right? Good. Then it's gonna step into here, and then boom, you have an error, right? So that's a runtime error. So everything's kind of cool. It's running, and then all of a sudden it hits to this, which doesn't recognize this, right? This is not something that exists, so that's why JavaScript kicks out this error. Okay, so that's the whole point of this runtime error. Okay, now, again, this is not something, this is really required for this class. It's not something I need to teach you for this class, but I thought I would just show you just as a point of interest. Let's say I took this out here. This line is the one that's generating the error. So let me take that out. Let me just clear off this error thing here. And then let me uncomment this, like that, and like that. Okay? So this has this concept of a try, a catch, and a finally, right? So this concept is called exception handling, right? It's catching error. You notice here's the culprit again, right? This is going to generate an error, but it's going to handle it a little bit more gracefully than the other way, right? So I uncommented, so this is all going to run now. So now watch. I run it, and then I click, right? Value 1, 2, 3. It's this 1, 2, 3. Yeah, because I left this guy in here. That's why it's doing it twice. Okay, my mistake. And value of B 1, 4, 5. And then you have the sum of A and B equals that. Um, and you can see error, undefined, right? Error, right? And then finally, that means this will always execute as the alert box here says. But you can see I didn't get like a quote unquote runtime error, right? I did get an error, but we handled it gracefully, right? And then we're done, right? And we're cool. So the program runs, right? There was an error, right? I did something I shouldn't have. This window dot print me here, okay? But the program didn't crap out on me. It kept on running, and that's the whole point of this try, catch, and finally, right? So again, this is a bonus thing. Don't worry too much about it. I just wanted to kind of show this to you just to say like there is ways we can code things to be what I would call and most people would call robustness of the program to handle things such as runtime errors. Um, but that's not within the scope of this class. This is just a nice to know type of thing. So again, what I just demonstrated here is a runtime error. Okay, everything's cool, it's running, and then boom, it hits an error and it craps out, right? And in this case, I just showed you a little bit extra bonus material in terms of handling these runtime errors in a more graceful way. Okay, so that's runtime error, right? So let me close this so I don't confuse anybody. Okay, and so now we get to syntax error. Syntax error, like I was saying before, like the program just flat out doesn't know what the heck is going on and can't do anything, right? So let's see what happened. And here, this is the culprit here, right? This little @ sign. So now I try to run it, and you can see I can't even do anything, right? I try to run it, and it tells you unexpected, right? Right. Forget about the fact that it didn't really give you the line number that you would expect, but basically this is the thing here, right? So the runtime error and syntax error, we could debate whether they're quote unquote easy to find or whatnot, but these are common errors, okay? And you know, I'll step into it when I do the example in the other video, but you know, generally, kind of the thing I like to follow is like, especially when you get into long programs, it gets into like how quickly you can isolate the issue, right? So you have a whole bunch of code, right? Like all that I'm showing you is one page of code, but normally a lot of more sophisticated code is going to be like pages and pages, right? And so you do your best. There's various ways to kind of, you know, comment code out, you know, split things up so you isolate things. Now the other part is when you're actually writing the code in the first place. I think we have a natural tendency, right, is just to say, okay, well, here's the assignment or whatever to tell us to write the code. And we just kind of write everything, and then we try to hit run. And more often than not, we probably have an error and it's going to not work, right, for whatever reason. But now you've already wrote a whole bunch of code, right? And now you have to kind of sift through and figure out where the error is. That's a bit painful, right? And God forbid you didn't really write the code in a nice way, so it's not really that easy to follow it. You're in a whole mess of trouble, right? So, you know, generally when I do coding, especially on larger programs, you know, I try to write them in small bits at a time and test them as I go along, right? That's the best way. So, you know, for example, you know, let's say this assignment that I've been seeing some questions on about doing the flowchart, you're taking a flight, I think, right? Either to Europe or Africa. It's a round trip. Is it a one-way trip or whatever? And if I was to turn that into a program where I have to collect that information, I have to understand, okay, which continent you want to go to. Are you doing a round trip? Are you doing a one-way trip? Are you doing like a grand tour? Are you doing like a simple tour or whatever? As I capture each of those bits of information, maybe I'll do like a print, right, or alert, I should say. Maybe I'll do an alert just to make sure I captured all the variables correctly, right, all the information into the variables correctly. You know, before I start to do anything else. Then I start to do like little things in terms of like decisions and calculations. Again, I might be doing some prints after that, or alerts. I keep on saying print, but say alerts after that. Just to follow along and say, okay, is this doing what I expected to do? Maybe I typed in the variable wrong, whatever, right? So all I'm saying is that as you start to write your code for your various assignments, inevitably, if you just write everything all in one shot, I think most likely you're going to have an error somewhere and you're going to have to do some troubleshooting. But if you kind of build it a little bit at a time and let's say do alerts like what I just showed here, you're going to find these issues sooner. And it'll be a lot easier than you having to look through like a whole long piece of code and figure out where your problem is. Okay, so just a little helpful tip there. Okay. So anyway, this is a simple one, right? This thing's not recognized and it crapped out, but it was just to highlight what a syntax error is. So let me close this one. Now this is the tricky bit. This is the logic error, right? So logic, it could be anything, right? You program something, it runs fine, or most of the time it runs fine, and then sometimes you get unexpected results, right? One of the worst things is if it goes into what we call infinite loop, right? And we haven't really talked about loops yet, so I don't want to talk too much about it. But basically, your program just goes crazy and just keeps on spinning forever, right? But here's another type of error here, right? So I think I mentioned at the beginning of class, you have things where you have the variable, not beginning of class, I should say, last week. You have these variables, right? And notice what I did here. Before it was being initialized at the declaration. So I declared the variable and I initialized it, just like on this variable b here. But here I changed it, so I just declared a variable. And you can see a very common mistake would be I declared it and then I decided I'm going to do something with it. Maybe for some strange reason or whatever, I just assumed that when I declared a variable that a would equals to 0. Well, that's not true, right? So, and you can see that very clearly when I do a equals to a plus 1, and then I try to print out the value of a. So let's see what happens when I do that. So I do that, and you get that, right? And in my prior semesters of teaching this class, as we do like various assignments, a lot of you are going to get this, right? Because of exactly this reason, not initializing the variable or mixing up the variable names. Hence why you want to have like more descriptive variable names. Just losing track of things or whatever. A lot of you are going to see this value of NaN, right? And that's essentially logic error, right? So everything's running fine, no problem, right? Until you try to look at that value in there and you realize that it's not what you expect it to be. Maybe you thought a would be 0, so you would expect a equals to 1. Obviously, that's not true, right? You needed to initialize this to 0 if that's what you wanted, right? So let me just do that here while I'm quick. And let's run it, and now you have 1, right? So this is what a logic error, one example. There's a lot of different ways logic errors can happen, right? Again, like the computer can't read your mind. Maybe you thought, B should be 0, right? For whatever reason. And somehow you got your wires crossed and you typed in A versus B. Maybe instead of doing like an add, you do like a division, or, you miskey it, right? You did a minus or something, right? Like that. Maybe you were thinking all the time you want to do plus, but somehow you typed in the minus, right? And then when you're looking at the result, you say, wait, how did I end up with that value, right? That's all examples of like logic issues, right? Again, I know it's very common. I know we didn't cover it yet, but it happens a lot in different types of loops, especially more complicated loops, like nested loops and stuff like that, where the value initialized it, and then as you're kind of going through it, yeah, you can lose track of it, right? In fact, I'll give you a suggestion. When we're doing like the exam 2, you're going to be given examples of code where we say, hey, what do you think the bug is here? Or what's the value of this after you go through this, right? So I might give you a number, let's say a equals to 0, and say, by the time this program's done, what do you think the value of a will be, right? That's definitely going to be on the exam, right? Just as a heads up, right? Not this exam, right? Not exam 1, exam 2, okay? So um, hopefully this gives you a quick intro onto this, right? Um, I think on the chapter it talks a bit about precision from a computer standpoint, some common issues. I think I mentioned it last week. Remember that JavaScript, you're talking about case sensitive. So very common mistake. People mistakenly put in something as lowercase versus uppercase or vice versa, whatever. They're different things. So if you try to refer to one thinking you're accessing one thing, but you're slightly off because of the case, it's almost like calling it a totally different variable, right? So you have things like that. You have things like, mistaking a 0 for a O or a 1 for a L, um, on those type of things. Unfortunately, computers are not good at reading your mind and anticipating what you were thinking, so it'll crap out, right? So those are very common types of issues. So it refers to that from the precision standpoint. Um, yeah, so that's that. Like I said, I'm going to cut you another video that actually has a debugging example. So hopefully between those two things, it gives you an idea of what to look for debugging. And of course, you have the resources from the book to complement that out. And if there's any comments about debugging or whatnot, just give me a shout. Okay, thank you.